Before moving on, I just wanted to do one more example problem out of POLYAs, just to try to work through and think about whether or not we can apply POLYA's problem-solving process. And you know what I'll actually do is I'll write right here on the video so you can try a couple of problems. So here is problem 2 from POLYA. It goes, you want a land which is exactly level with 4 boundary lines. So you want exactly flat, exactly level, with 4 boundary lines. And here it goes, you want to run exactly north, south. And the other two, so not the same two, run exactly east, and that should be capital, to west. Each measures exactly, and it says 100 feet. Can Bob, so Bob wants a parcel. Can Bob buy this in the U.S.? So I'm not going to do this one, but I think there's an obvious picture to draw, and I think maybe choosing the right picture might be important for this problem. So that's a problem you can maybe try on your own and discuss. I already did the next one, which is 10 pockets and 44 silver dollars. So problem 4 out of his book is, can you, using a printer uses 2,989 digits. How many pages? And I think the idea is the number 123 equals 3 digits. And if the next one is 124, that means you've used total 6 digits, if that makes sense. So the total number of times a digit is used. Problem number 5 is, a grandfather's had a bill. He bought 72 turkeys for blank 67.9 blank dollars. So there's a bill, and then you don't know what these numbers are. And what are they? These are turkeys. And I mean, there's more, so I guess some of those you could try to think about. And I think I will look at this one. So the question is, how many pages require 2,989 digits? So for that, let's see. We know that if you use one page, it only takes 1 digit. So I guess the strategy I'm doing is I'm kind of breaking it down into the simplest problem I can think of. 0 pages take 0 digits, so that's not interesting, but I can mark it down. 1 page takes 1 digit. 2 pages take 2 digits. and I can see that that pattern is going to continue on. 9 pages take 9 digits. 10 pages is going to take the 9 digits plus 2, so 11 digits, because I had a 1 and a 0, that's 2 more digits. Similarly for the 11, that adds 2 more digits, so that would be not 12 but 13. And I think I see the pattern up to 99, it's going to take 2 digits. And then, so I don't want to do all of those. So I can see I have 9 one-digit pages, and up to 99, that is, I guess 99 minus 9 equals 90 two-digit pages, which gives me a total of 2 times 90 plus 9 equals 189 digits used so far. So I think what I'm going to do is I can take that logic pretty easily, and I can keep building up until I pass this target. I'll either pass it or hit it, and then maybe I can begin to work backwards from there. So the number of 3 digits is going to be, so that gets you up to 999, but 99 I've already taken care of, so that would be 900 3-digit numbers. So if I do 900 3 digits, then what is that? 2700 3 digits plus, again we still have 180 plus 9, and that is, we're already there. That is 2189. If we add those 3 together, right? 2700 plus 180 is 2880. Oh, hold on a second. Let's add these together. I shouldn't skip, because I skip incorrectly. So 2700 plus 180 is 2880. And if I add the 9 in, I get 2889. And what I'm looking for is 2989. So with 999, this is 999 pages. So with 999 pages, we've gotten 2889. At this point, digits used, 2889 digits used. At this point, every page is going to require 4 digits. So I'm off by, it looks like I'm off by 100 over here. So I'm looking for 2989. So 4x equals 100. That gives me x equals 25. So if I have 25 pages in above in the 4 digits in the thousands, then I expect to get 2989, which means that I would have a total of 999 plus 25 equals, and forgive me, I am not super fast in math. That was obvious, 1024. So I suspect that there were 1,024 pages, and I got that by starting from a very small problem and working my way up. But I need to check this now. So 1024 is 25 4-digit numbers in the thousands, plus 900 3-digit numbers, plus 90 2-digit numbers, plus 9. And I wonder if I could generalize this. So well, I'm going to stop there. The answer is probably 1024. I can do this again. This is 100 plus 2700 plus 180 plus 9, and we've already done that math. This is 2800. This becomes 2980, and this becomes 2989. Check. All right, I will stop this recording there, and I think maybe what I'd like to point out is this was one of POLYA's problems. I didn't look at the hint. What I did, if you're paying attention, is I guess I found a related problem. So the inverse, right? So if I have one page, how many digits does it take? It wants you to go the other way around. And I just kind of did a brute search. And I just said, if it's one page, how many digits? If it's 2 pages, how many digits? So I started very, very small and worked my way up until I could find a pattern. And then I took that pattern and I continued it up as far as it would take me. And once I knew the pattern, at some point, I mean, this is based off of that pattern, right? I knew that because of the pattern that once I got above 1,000, every number was going to take 4 digits. So I was able to figure out what I needed to solve to get there. Baby steps, right? You don't just look at it and find the solution. You kind of work your way up. And let's see what POLYA's hints are, and then let's find out if I was correct. So the big challenge is to know whether you're correct on your own. Unfortunately, other than looking at the soundness of this argument, I'm not quite sure how to check it because no, I mean this is pretty straightforward. Let's see what POLYA has as the hints. This was problem number 4. Okay, so I can tell you that problem number 4, the hint is this. If you have exactly 9 pages, how many digits do you use? So that's a related problem. And we hit that problem, right? We did that. We looked at a very small number of pages, like 9. If the book has exactly 99, how many digits do you use? That was this problem. So we did that. 99 is 90 times 2 plus 9. We hit that problem as we worked through. So we kind of were able to, by starting small versions of the problem and working our way up, able to basically get his hints. And then he arrives at a solution of the same thing. So you get 9 plus 2 times 90 plus 3 times 900 is 2889. And so then we need to look at 4 times x minus 999 to get the number of pages missing. We kind of worded the problem a little bit differently, but we end up with the same number. We get x equals 1024. and that's the right solution. So there we go. There's another sample of trying to solve using Polya's method. You guys can look at these other problems and try to ask yourself if you could, again, taking this idea of looking at the big problem and trying to figure out, drawing pictures, establishing notations, and finding sub-problems or smaller problems, seeing if you can solve these puzzles.